Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're talking about reactions of alkenes, remembering that alkenes are a type of hydrocarbon and they're characterized by having a double bond in between the carbon. This is different than the alkanes. They sound similar, which are saturated. They have a single bond in between the carbons. So today we're talking about alkenes. A typical alkene, for example, would be ethene, which looks like this as the displayed formula. It has the double bond. Remembering carbon can only be bonded to 4 other things. And so we're going to put hydrogens around it as a hydrocarbon, hydrogen and carbon. And we call this particular molecule ethene. So we're going to use ethene as an example for the different reactions. The first reaction is a combustion reaction. Like most hydrocarbons, alkenes can undergo combustion, and combustion is when we react with oxygen, and complete combustion will form water and carbon dioxide. This is complete combustion. Alkenes can undergo complete combustion, but they tend to undergo incomplete combustion. So incomplete combustion, we're going to see carbon monoxide forming plus carbon plus a bit of water. Now we know the difference between incomplete because of this. Complete has carbon dioxide, whereas incomplete has carbon monoxide and solid carbon, which we can also call soot. So that's the black solid carbon that you'll see in the form of smoke or ash. So alkenes, while they can undergo complete combustion, they tend to undergo incomplete combustion. And that's important to distinguish that, whereas alkanes undergo mostly complete combustion. They're easy to burn. The second reaction that we want to look at for alkenes, and we use ethene as an example, is the addition reactions. So in an addition reaction, we're taking alkene and we can add it, for example, to a halogen molecule. And that will form what's called an haloalkane. Addition reactions, we notice that you have two reactants, which will yield one product. So 2 goes into 1, and we call that an addition reaction. We can actually look a bit closer at how that looks. And we'll use ethene as an example. So let's draw the ethene molecule again. So here's the ethene. And we're going to add a halogen molecule, for example, bromine, which is Br2. And in fact, I'm going to change this as a different color so we can see where they go. So here's the bromine molecule. And each bromine atom is going to add on to one of the carbons. And so the reaction will look like this. The product will have the same carbon to carbon, but now we form an alkane, which is now going to be saturated with the hydrogens around it. But now we're going to have bromine atoms attached where the double bond was. And we still use the prefix eth, but now we call it 1,2-bromo ethane. Ethane, because it's now an alkane because it has a single bond in between it. And we call this an addition reaction. We can now look at some other reactions. They're also addition reactions, but we're going to use different reactants to do it. So reaction number 3 is an addition reaction. But in this case, we're going to add water. So we're going to use ethene again. And we're going to add water, but we're going to write the water as a somewhat displayed formula like that. In fact, let's use the different colors. That way we can see what's going where. And again, these different atoms are going to add to the double bond. And let's look at the product. So we're going to get back an alkane, but it's going to be a special type. And when we add the hydrogen to one side and the OH to another side, we see that we now form an alcohol functional group. In this case, because it has 2 carbons, it's called ethanol. So we need to remember as a word equation that alkenes plus water, still an addition reaction, so we only get one product, yield alcohols. Let's look at reaction number 4. This again is going to be an addition reaction. But we're going to use, in this case, a hydrogen halide. So for example, hydrochloric acid. I'm going to use, again, ethene as an example. Each carbon can only bond to 4 other things. And I'm going to add the hydrochloric acid. Same process, the hydrogen, each atom adds across the double bond. And now we get back an alkane. So we need to break the double bond, write out the hydrogens that were already there. And now we add the 2 atoms. And you can see we've formed another haloalkane. This is another haloalkane because it contains a halogen and an alkane. In this case, we're going to call this chloroethane. Chloroethane. We know it's an alkane because it has a single bond in between the carbons. We call it a haloalkane because it has a halogen group attached. Finally, There are also some tests for alkene, or there is a test for alkenes, and that involves using bromine water. Now, bromine, which we saw earlier, Br2, has an orange color. Bromine water, aqueous, has an orange color. But when you add it to an alkene, the solution is colorless. If you were to add that to an alkane, because they do look similar, bromine, which is orange color, to an alkane, there would be no color change. It would remain orange. And so the test for alkenes is using bromine, and if the solution goes colorless, we know that we have an alkene present. And because alkanes and alkenes look quite similar, this is a very important test for alkanes and alkenes. There is one more reaction. It's very, very similar to the rest of them, and it's called hydrogenation. I think we're on reaction 6 now. So if we take that ethene again, and if we add hydrogen, which is diatomic, but we're going to display it out. Like that, as a displayed formula. Again, the same thing is going to happen, where the hydrogen is going to add, the atoms will add across the double bonds. This now becomes an alkane rather than an alkene. And we can represent the 2 additional hydrogens with a different color. So we can see this is a good reaction where an alkene, plus hydrogen is going to form an alkane. So this is a way to actually make it saturated, is to cause the alkene to become saturated. And we call this, because we're adding hydrogen, hydrogenation. Okay, and this is very useful, for example, when they make products such as margarine that people use, they consume margarine, it's by taking that unsaturated oils and fats, and they can saturate them with hydrogen to form an alkane. And alkanes would tend to be more solid at room temperature. So this is a very important reaction. So those are the main reactions of alkenes that you need to know. If you're not sure about how to name alkenes, you can go and watch my video on Intro to Organic Chemistry. Please like and subscribe. Leave a comment below. Let me know what videos you'd like me to do.